Hello, today we are finishing up chapter 7 with section 7.7 on page 16. I can multiply polynomials. So what we'll do is we'll review a few rules first with our warm-up problems and then talk about multiplying monomials and then crank it up to multiplying polynomials. So go ahead, write the target and then go ahead and try warm-up questions A, B, and C. All right, well, hopefully you had a chance to try them. And so we have 2 to the third times 2 to the fourth. We have these like bases, so we can add the exponents and get it to be 2 to the 7th power, okay, which really is 128. That's the product rule. We'll be doing that. We'll be using the product rule a lot today. If you needed to, we could have also expanded 2 to the third. Is 2 times 2 times 2, and then 2 to the fourth is 2 times 2 times 2 times 2, and we have 2 to the 7th power. And letter B, we have a power raised to a power, so we can multiply the exponent. So 5 to the 6th power, okay? And you can evaluate that. I believe 5 to the 6th power is 15,000 something. I'm not sure, I don't have my calculator near me. But 5 to the 6th, again, we're using the power rule. And because we have a power raised to a power, we can multiply. And so let me figure out what 5 to the 6th power is real quick. It's like 15,625. There it is. All right, and letter C. We have a couple 2 pencil mark tricks, and we're going to distribute. We're going to use the distributive property. We'll also be doing this a lot today. 4 times 2x squared is negative 8x squared. Negative 4 times negative 5x is 20x. And negative 4 times negative 7 is positive 28. All right, so we have a couple rules that we reviewed from earlier chapter 7 and distributive property. We've seen that all year, and we will be working with that when we multiply. All right, so multiplying monomials. All right, remember your exponent rules for multiplication. If we multiply 2 terms with common base, what can we do with their exponents? So let's look here. If I have x times x, I really have x to the first times x to the first. That's really x squared. So what can we do with the exponents? We can add them. Okay, think product rule. All right, so let's go ahead and let's look at these examples. All right, when I take a look at number 1, a few things I'm going to notice. In between my parentheses, there is no operation, so I will put a multiplication symbol in. I'll do that for each of these. If it's any other operation, it will be there. So if we're adding these, there will be a plus sign. If we're subtracting, there will be a minus sign, okay? So if there's no symbol there, we put a multiplication symbol. So now what we're going to do in number 1, we're going to multiply the numbers together, right? 6 times 3 is 18. And then I have y to the third times y to the fifth. I have the same base, right? So y, and I have these exponents, so like bases, I can add the exponents. I have y to the 8th. If you wanted to use the commutative property, because you can do that with multiplication and addition, we really could rearrange this. So we had 6 times 3 times y to the third times y to the 5th. And we still would get 18 y to the 8th power. So let's look down at number 2. Okay, so again, I'm going to be looking for anywhere I need to add a 1 for an exponent. So this m is to the first and that n is to the first. Let's look. 3 times 9, 27. I have m to the first times m to the second. So I'm going to look at my exponents. 1 plus 2 is m to the third. And I have n to the second times n to the first. So n to the third. So my final answer is 27 m cubed n cubed. Go ahead and try number 3 yourself. Remember how to put a fraction into the calculator? open parenthesis, 1 divided by 4, close parenthesis. Hit pause and see if your answer matches mine. All right, you should have a final answer of negative 3s to the third, t to the fourth. All right, when we multiply a monomial times a polynomial, okay? So monomial, meaning one term, times a polynomial. In this case, we have a trinomial. In this case, we have a binomial, okay? We must think distribute. Just like we did up in the warm-up problem, right up here where we distributed. Do the same thing for number 1. I'll 2 pencil mark trick, so I make this a plus -8. And I'm going to distribute to each term. So 4 times 3x squared is 12x squared. 4 times 4x is 16x. And 4 times -8 is -32. There's nothing I can combine here. I have an x squared, an x, and then no variable as a base. So this is my final answer, 12x squared plus 16x plus -32. All right, number 2. Now, looks like it's a little different than number 1. So I'm going to put some exponents here, and I'm going to make that a plus negative, and I'll throw a 1 in there, so I know what my coefficient is, -1. And so again, I'm going to think distribute. I'm going to multiply my monomial times my first term in my binomial. So 6 times 2 is 12. And then I have p to the first times p to the first. Well, that's really p squared. And then I have q to the first, but I have no other q's to multiply it in this term. So I'm just going to leave it as q. So I have 12p squared times q. And then now I'm going to multiply the monomial times the second monomial. So 6 times -1 is -6. P, there's no p's over here, right? No p's over there, so I'm just going to leave it as p. But I do have a q to the first times q to the first, which is q squared. Now, I cannot combine them because I have p squared times q and then p times q squared. So this indeed is my final answer. Now, there's something called the box method, which is like the Punnett square of math. And I'll show that to you once we get down here to a binomial times a binomial. Some people choose to use the box method when we do a monomial times a binomial. So it would just be a 1 by 2 box. But I'll show you where down here, number 1, multiplying a binomial by a binomial, where it is most efficiently used. So let's crank it up and do a binomial times a binomial. I want you to write box method. I like the box method because it does not tap out as FOIL would. I do also want you to write FOIL over on the side. When you work with IXL or even somebody older, and they might say, oh, just FOIL these. Well, FOIL really means first, outside, inside, and last. In the order you multiply the terms. The box method is another strategy, just like FOIL is, in how to use the distributive property when you're multiplying polynomials. The box method you can use for even a 5-term polynomial times a 4-term polynomial. So it's limitless, right? This one is limitless in the sense that you can make a box however big you want to. So we're going to focus on that. So we're going to multiply a binomial times a binomial, which means 2 terms by 2 terms. So I first want you to make a big box where you can write nice and neat inside. And I'm making, again, a 2 by 2 box because I have 2 terms. So I'm going to write the first binomial going down the left-hand side. and then x and 3 across the top. You could absolutely switch them, right? X and 3 could be over here and x and 1 up above if you wanted to. I typically put my first term going vertical. It doesn't matter because it's multiplication. You'll get the same answer. So now what I'm going to do is I'm going to see, well, what number goes inside my yellow box? Well, I'm going to multiply x times x. And x times x is x squared. Product rule, right? These are the first power. Now I'm going to multiply 1 times x and fill in this box. 1 times x is 1x. To fill in this box, I'm going to be multiplying x times 3, which is 3x. And then to fill in my last box, I'm going to be multiplying 1 times 3, which is 3. Now that I have my box completed, I can go ahead and write my final answer and simplify or combine any like terms. So I use the product rule because I'm really multiplying to get my answers within the box. Now I need to take a look, and I don't have any other terms that can combine with x squared. So I'll keep x squared. I'll put a little check mark in that box so I know I've used it. Then I'm going to look at any like terms. Well, I have 1x here and 3x there. Well, when I combine them, I have 4x. Okay, some people like to circle them. And then there's nothing to combine with 3, so I'm just going to write plus 3. So there's my final answer. I have x squared plus 4x plus 3. Let's look at number 2. Again, a binomial times a binomial. I'm going to make a 2 by 2 box. 2x, 4, 3x, and 2. To come up with this box, I'll do 2x times 3x, and I'll get 6x squared. In this box, I have 4 times 3x, which is 12x. Now this box, I have 2x times 2, which is 4x. And then this box, I have 4 times 2, which is 8. Let's go ahead and let's pull the final answer out of the box. So I have 6x squared plus, well, look here, these two can be combined. 12x and 4x make 16x, and then plus 8. There's my final answer. So you can see how it is similar to a Punnett square. Now let's go ahead and let's look at number 5. Okay, so this looks like I would just distribute my 2, right? I would just distribute that. Well, no. Remember, that 2 is telling you how many times this base is being multiplied. So the first thing we need to do is expand. I need you to write that. Expand. Because now we see it's really x minus 4 times x minus 4. And now I can create a box. All right, now I can also 2 pencil mark trick that, so it's plus negative 4. And I'll write the negative 4. Okay, so x negative 4, x negative 4. Notice I didn't write the plus signs before because they're assumed that they're positive numbers. All right, go ahead, hit pause, and then you fill out the box and check it with my box. Okay, hopefully we have x squared, negative 4x, negative 4x, and 16. After you have the same box, hopefully we can combine any like terms and get a final answer of x squared plus negative 8x plus 16. And there's our final answer. So again, the box method is just a method used to use a strategy to use the distributive property. So that's binomial times a binomial. So we're making a 2 by 2 box. Now, multiplying a binomial times a trinomial. So if I take a look at my problem here, I have 2 terms and 3 terms. I will need a 2 by 3 box. And yes, you need to make sure the x and the 2 in this case are in the rows where there's only 2. Okay? 2 pencil mark trick that middle term. I have 3x squared, negative 4x, and 3. Now, some of you may write a 2 by 3 box this way. And that's totally fine as long as you have the x and the 2 up above. And you can have 3x, negative 4x, and 3. You should get the same exact answer. Okay? But I'll be doing mine this way. And now with the same process. So x times 3x squared is 3x to the 3rd power. 2 times 3x squared is 6x squared. X times negative 4x is negative 4x squared. 2 times negative 4x is negative 8x. X times 3 is 3x. And 2 times 3 is 6. So now I'm going to look within my box. Standard form, highest degree to lowest degree. I don't see anything with an x cubed to combine, so I have 3x cubed. I also can see that now I have a 6x squared and a negative 4x squared. When I combine those, I have 6x squared and negative 4x squared. I'm left with 2x squared. I can also combine negative 8x and 3x to have a negative 5x, and then plus 6. So a binomial times a trinomial typically results in a 4-term polynomial. But using the box method is the way to ensure you distribute every term to every term. And finally, a geometry application. All right, so we have a length of a basketball court is represented by x plus 2, and the width is represented by 3x minus 1. Right, a polynomial that represents the area of the basketball court. So now, if I didn't have a basketball court picture drawn here, I could absolutely draw a rectangle. Okay, hopefully you guys already have the width and the length labeled, but if not, that's what I want you to do first. So in the last section, we asked about the perimeter, meaning the distance around the court, right? So if I wanted to add up all these sides, I'd be able to find the perimeter. Well, this problem, we want to find the area. And the area of a rectangle is length times width, which means I'm going to take my length and I'm multiplying it by my width. So I have x plus 2 times 3x minus 1, or plus negative 1. And so now I'm multiplying binomials, which means I can make a 2 by 2 box. Go ahead, hit pause. You complete the box and even try to bring out the final answer from it. And we will compare answers. Okay, hopefully you have 3x squared, negative 1x, 6x, and negative 2. And your final answer should be 3x squared plus 5x minus 2 units squared. When we're talking about area, it's units squared. So this is the lesson on multiplying polynomials. All right, thanks for watching.